Hey gang, so this is the unit 3.3 and this is geometry and trig still, but this is going to be a unit on application. So we're not learning anything new, we're just going to apply everything we know about triangles and trig ratios and everything. So this is just a whole lot of examples. Alright, so in triangle ABC, and most of these I'm going to already have the picture drawn out for you. AB is 6.5, BC is 4.2, and angle BCA right here is 65.6. Calculate the area of the triangle. All right, so let's see, what do we know about area? Well, we had that formula, and I wrote it down earlier. Area of a triangle, we know it's 1/2 base times height, but since we don't have I guess we could draw the line here and we could try and find this side right here, but it might be kind of hard trying to find it. We could, if we drew this down right here, if I came down right here with a right perpendicular line, I guess I could do opposite over hypotenuse and I could find the height, and then I could do 1/2 base times height. That would absolutely work. Like if you wanted to do that, you could absolutely do that. You would do Pythagorean's theorem. Or no, you wouldn't do Pythagorean's theorem. You would do, let's see, opposite and hypotenuse. So some old horse. So you would do sine of this is this over this. Figure out this, and then you could do 1/2 base times height. But you know what? You don't even know the base on this. So I don't even think we could do that now that I sit here and look at that. The only thing that I know would work is just the general rule. If you have a triangle, you can do 1/2 A times B times the sine of C. That's the only thing I know that would work. Now, the only catch on this, if you remember when we were doing A, B, and C, the angle has to be in the middle. So I would need to know this side right here. It would be 1/2 A times B times the sine of this angle right here. So in order to use that, I'm going to have to figure out this side. Now, the other thing is if I wanted to do 1/2 base times height, I can figure out this height pretty well, but I still don't know this. So I would still have to find that. So either way you go about this, as you sit here and you look at it, whichever way you want to do it, we're going to end up having to find the sine, this side over here, x. So let's do that. Remember when you know an angle and a couple of sides, the easiest way to find it is that cosine rule. So c squared equals a squared plus b squared minus 2ab cosine of c. And remember, the angle is going to be between the two sides. So that means c squared, the opposite side, is going to be the one furthest away. So that's going to be 6.5 squared equals, I'm going to do 4.2 squared plus, and this would be the other side that I don't know, I'm going to call it x squared minus 2 times 4.2 times x times the cosine of 65.6. So let's simplify some of this. 6.5 squared is 42.25. This is 17.64 plus x squared minus 2 times 4.2 times the cosine of 56. I'm going to multiply all that out, and I got 3.47 times x. All right, when I see x squared, unfortunately, I'm thinking, okay, we got quadratics here. So I'm going to move this 42.25 to the other side. Zero equals. I'm going to rearrange this into quadratics. I'm going to put the x squared first, minus 3.47x, minus, and this is 24.61. All right, so here's what I end up getting. X squared minus 3.47x minus 24.61. Well, remember, anytime you get quadratics, especially these decimal ones, we're going to go to our polynomial solver. So we're going to go to our apps. You're going to find the one that says Polynomial Solver. Mine's number 9. Others of you had a different number, but as long as you have it on there, you're fine. We're going to do the Polynomial Root Finder, which is 1. The degree is 2, so I'm going to go to Next. And I'm just going to plug these in. So in front here is a 1. 1, enter, enter. Negative 3.47, enter, enter. Negative 24.61, enter, enter. I'm going to solve it, and I get 2 numbers. I get x equals negative 3.52 and x equals 6.99. I'm just going to put 0 on both of those. So I'm finding the length. Length can't be negative, so I'm going to mark that one off and say it can't be that one. And I'm going to go up here, and I'm going to now use this rule right here to solve it. So area equals 1/2 A, I'll just call that 4.2, times B, which I know is 6.99, times the cosine, I'm sorry, kind of the sine, not cosine, don't do cosine, times the sine of 65.6. I should have left myself more room there. All right, so the area equals 1/2 4.2 times all of that. I got 13.3679. And we're going to do 3 sig figs, so the area is 13 point. The 6 is going to round the 3 to 4, and it is centimeters. It's area, so it's squared. All right, example 2. ABCD is a quadrilateral. AB is 40, BC is 50, CD is 71, AD is 30, and I've got it all drawn out there. Angle DAB is 90. Find the area of the quadrilateral ABCD. Give your answer correct to 1 decimal place. All right, so I got a kind of a funky little shape going on here. I was looking to see if I had a ruler, and I don't. So what I think I'm going to do is I'm going to create a triangle inside here, because there's no way to really find the area of that. So I'm going to connect those right there. So I see a triangle here, and I see 2 sides on this triangle. I see a triangle here, and I see 2 sides and a right angle. I'm going to go ahead and figure out this triangle right here, 1/2 base times height, right? And so that one will give me, that'll be pretty easy. So I'm going to say, well, and let's write this out here. Triangle ABD plus triangle, we'll call this CBD. The area equals, I want to add those 2 together, right? So if I take triangle ABD, this one's pretty straightforward, 1/2 base times height. And again, I'm doing this one right here. So area equals 1/2. The base is 40. The height is 30. 40 times 30 divided in half. 1200 divided in half. We'll just do it on here just to make sure. So 40 times 30, and we'll divide that in half. So we're going to get 600 meters. It's area squared. All right, so that gets this one right here. I know this one. So I need to figure out the other one. So in order to do that, remember, you either have to know all 3 sides if you wanted to use the cosine rule. Because like if, no matter what I try to use, I don't know any angles inside here. I don't know any angles anywhere. And so I really, if I could just find DB, that would be helpful. Because when you know all 3 sides of any triangle, you can find the area with the cosine rule. So let's figure out DB. Well, this is a right triangle here. I'm going to do this. I'm going to cover it up. If I just look at this, I I could say that 30 squared plus 40 squared equals dB squared. Okay, so let's do that math real quick. 30 squared, 30 squared plus 40 squared is 2,500, and we're going to take the square root of that and get 50. So, dB equals, I'm going to just say the square root of 2,500. I'm going to put a little bit of math in here. dB equals 50. Okay, so that means that this side right here is 50. I know that the area of, we'll call that, what do we call it? CBD. I'm going to do C squared plus O equals, sorry y'all, C squared equals A squared plus B squared minus 2AB cosine C. And remember, whenever we're working this, we're going to figure out, what could we figure out on this one? I have a note here that I could have just used my sides. I could, in order to find this, I could figure out this angle right here, which is kind of what I did. But remember in our notes, and I'm trying to remember where it was. Let me see if I can find it real quick, and that way I can show you, because I think it might be helpful. Okay, so I was double checking. The formula that we used in our notes, it said to find an angle, it said angle C would be, and we took the two opposite sides and we said A squared plus B squared, and then we subtracted off C squared, and we divided by 2AB. And then we took the inverse cosine of that. And so that was kind of a shortcut. It's basically this right here already solved. And what that's going to do, it's going to give us this angle. And then in order to find the area, we're going to do 1/2 AB sine theta. Okay. The only one we have for area, we don't have one for cosine with area. We only have the one for sine. So we have to find this angle right here. I'm going to call it theta. We have to find that angle in order to find the area. In order to find that angle, we're going to use this rule right here. If you want to use this one, it's a little bit easier. This one's not in our formula booklet, so you have to memorize that one. But this one right here is in our booklet. It works every time. And we're just going to do the math. This is a lot more algebra. So this is the angle I want to find. So opposite it is going to be the C squared. Okay, so that's going to be 50 squared equals A squared. I'm just going to call A 71 plus B, which is going to be 50 squared, minus 2 times 71 times 50. And then we're going to have cosine, and I'm going to put theta here because that's what I'm calling it. The algebra involved right here ends up being this. Okay, so we're going to have 71 squared, 50 squared. So let's see, 50 squared will be, I actually didn't do that in my homework. 2,500. I should have known that. We just did that. Sometimes you forget. Let's see. 71 squared plus 50 squared. I'm going to go ahead and do that math. 71 squared plus 50 squared. 7541. Minus, and I'm going to do 2 times 71 times 50. 7,100. Cosine theta. All right. I'm going to subtract 7541 from both sides. $75.41, and I'm going to subtract 2,500, but remember I'll have to switch the negative, so that'll be negative 5041 equals negative 7,100 cosine theta. I'll divide both sides by 7,100, so I'm going to take this and divide by 7,100, and it's 0.71. Now, if you did it the other way, you would have gotten the other answer. And so we'll do the inverse cosine of that. Let me move that up a little bit. Second inverse cosine of 0.71 And we get that theta is about 44.765. Okay, so we know now what theta is. Once we know that, we can go back and we can find the area. So the area of ABD was 600. The area of CBD. So I'm just going to go here. The area of CBD equals 1/2 A. And remember, when we do this, it's going to remind you you're using this right here. Sides have to be touching the angle. 1/2 71 times 50 times the sine of this right here. 44.765. All right, so here we go. Clear that out. 0.5 times 71 times 50 times, and I'm just going to go back up and I'm going to say sine, and I'm going to move up here. That's that angle I just found, just so I have all the numbers in there. A little more accurate. Probably won't change it much since we're going to round. All right, so the area equals 1249.95. I'll do 79. Okay, that's the area of this. Remember, that's the area of this one. So I'm going to take that. Oops. How about we do? There we go. I'm going to take that one plus the 600 I found earlier. All right, the total. I'm just going to put total over here. Equals 1/8. And just so I don't have to do it again, give your answer correct to one decimal place. 1/8. Okay. The 5 is going to round the 9 to a 10. The 10 is going to round the 9 to a 10. And the 10 is going to round the 4 to a 5. So I'm going to end up getting 1850. They wanted a decimal, so I'm going to put it there. Meters squared. All right, moving on. So we've got a picture on the next one. In the picture below of river surveyors in France are using triangulation to find the width of the river Seine. I don't know what that is. Angle D is 82. The length of the base of DA is 10, and the angle A is 90. What is the width of the Seine to the nearest meter? Okay, so I don't know if you can see this really well, so I'm going to draw it over here. I'm actually going to change colors. This pen is dying on me. So here's my surveyors. They've got a right angle right here. You can see the little guys looking across. Up here, I'm going to call this B. I'm going to call this A. And I believe they call that right there D. All right. They tell me that angle D, which is right here, they say that this is 82 degrees. They say the width of the Seine is what we're trying to find. D to A is 10. And that is all they give me. So this one should be straightforward, guys. They want to know the width. So they want to know this right here. What is, I'm just going to put a W here for width. I'm going to give you a second to look at it. If you find the answer, it's 71 meters. I've got the angle right here, and I've got to figure out this. So it's a right triangle. I've got right triangle trigonometry. This is the side opposite. This would be the side adjacent. I'm going to just focus this one more time. Which trig function involves opposite and adjacent? SOA, TOA. That would be tangent of theta equals opposite over hypotenuse. So that means tangent of 82 degrees equals opposite over adjacent. Remember, anytime you're doing degrees, make sure that you are in degree mode, not in radians. So I'm going to do tangent of 82 equals that. I'm going to multiply, so the 10, remember to get rid of the 10 on the bottom, you multiply by it on both sides, so times 10. And I get 71.15 equals W. I'm going to round it up to the nearest meter, so the 1 will not round that, so it'll be 71 meters. All right. Okay. All right. So let me read this one, and we'll work with it as we go. So a land surveyor measures the initial angle to the distant tree at 67 degrees. She walks 5 kilometers and measures the angle to the same tree from the baseline to be 36 degrees. She measures the angle between the viewing lines to both the landmarks as 113 degrees. She then walks 6 kilometers along the baseline, CE, where the base angles are 49 degrees and 30 degrees. You can see her sketches in the diagram below. Yeah, because that was a whole lot of information. Find the distance between the two landmarks B and D to the nearest kilometer. So find the distance between B and D. So they even labeled it X. All right, so what do you think? My problem is to find the distance between these two landmarks. And on this triangle, if I look, the only thing I know is an angle, that's it. So in order to solve this one, I need to know more about this triangle than I know. I need to know these lines right here. So what I think I'm going to have to do is look at the two smaller triangles to figure out this missing side. So what I'm going to do is cover these up. And I'm going to focus on these one triangle at a time. So looking at that triangle, how can I find the length of BC? We want to know the length of triangle BC. Give you a second to think. So here's what I'm thinking. I like to use the sine rule because it's easy to remember, and when I can use it, I like to use it. Well, in order to find BC, I would have to take the sine of this and put it underneath this side, but I'd have to know this side to that side, or because I don't know this side, I can't do 36 over this because this is an unknown. But if I knew this angle right here, I could put this ratio over this ratio. I know that angle right there, don't I? Because I can take 67 plus 36, subtract it from 180. I'll just do my calculator real quick. 180 minus 67 minus 36, 77. So that means this angle right here is 77. So I can set up that ratio. 5 over sine of 77 equals, I'm going to call this X right here. Or B, let's call it BC. I think that might be better. Let's say side BC over sine of 67. Okay, cross multiply that. I was looking on my notes to see where I had BC. I don't think oh, there it is. I got 4.7235. Okay, so now I'm getting there. I know this one. And in order to find that length, I need to know this one and that one. All right, so now I'm going to cover up this one. Actually, all of this. Let's see if we can find CD right here. Same kind of situation going on here for CD. I can do sine, I'll call this, we'll call this Y. Or actually, no, we'll call it D, CD. CD over sine of 30 equals, do I know this angle right here? Well, I can sure figure it out. 49 and 30, subtract it from 180, it's going to be 101. So I could do 6 over sine of 101. Cross multiply all that. I ended up getting 3.05615. Okay. So I I know a lot of information now. I can find the missing side. I have that cosine rule that says two sides in an angle, bam, I can find the opposite side. So remember, you take the opposite side of the angle you know and you square it. So in our case, it's going to be x squared equals. We're going to add the two sides together and then minus 2 times each side cosine of 113. So I'm going to take BC, which is 4. I'm going to do all of these numbers right here. 4, 7, 2, 3. I'm probably going to run out of room. Squared plus, I'm just going to do 3.05. I'm going to use my calculator to find it, but for now I'm just going to put those in because I don't have enough room. I'm going to squeeze in cosine of 113. But you know it should be right there. All right, so here we go. X squared equals. I'm going to go to my calculator, and I'm going to plug in these numbers. Clear all this out. So I'm going to do 4.7235 squared plus 3.05615 squared minus 2 times 4.7235 times 3.05615 times the cosine of 113 degrees. All right, so I got 42, so x squared would be 42.9324, on and on and on. I'm going to take the square root of that, 6.5522, so x equals 6.5522, and we are doing to the nearest kilometer, so x would be, 5 is going to round the 6 up, 7 kilometers. And there's my answer. Okay, so that's just some application using that cosine rule, the sine rule, almost to the extreme. That is definitely some tough pre-cal type questions. Now, 3.33, that is bearings. Bearings, I think you have done in pre-cal. I don't think you do bearings in Algebra 2. I don't remember ever seeing that there. But bearings is where, like if you're going into aviation or sailing boats, I don't know what that's called, a ship captain, you're going to be using bearings a lot. If you travel, like these are all your bearings. You've got due north, and then it goes northeast, east, southeast, south, southwest, west, and northwest. You're going to always start on your north, and when you talk about the sailing or the going, you always start and you go on the outside, okay? And we'll do that more. The directions for the reading are like this. So if I said you were traveling at 100 or let's say 95 degrees, you would start here and you would travel. You know that to right here is 90, but then you would go 5 more. So if I wanted to go like 74 degrees, let's mark 74 degrees. So I would start due north. 74 is going to be about right here. And the way I would draw it is I would go down like this, and I would say that is 74 degrees. Okay, if I wanted to do 124 degrees, I'll do that in a different color. I'm going to go, that's about right here. So I would start at north, and then I would go all the way down to 124 degrees. Okay, just so you can kind of get the feel for that. You make a note here that you read clockwise. Once we do a problem, it'll probably make a little more sense. Just remember, we're going to read it clockwise. Oh, sorry. All right, so here we go. I'm going to turn the light on my camera and see if that helps a little bit. I feel like it's kind of dark. Yeah, that helps a little bit. Okay, so a ship leaves a port and travels 40 kilometers on a bearing of 40 degrees. Due north, here we go. You notice how we've got 2 norths on here. after changing direction. So first off, let's just take this. He leaves the port. He's right here. He leaves port, and he's traveling at 40 degrees. So remember, you read clockwise. So this angle right here is 40 degrees. After changing direction, so he's this way and he changes direction, he continues to travel another 70 kilometers. So he travels 70 kilometers on a bearing of 120 degrees. So that means you start from north and you're going to go 120. How far is the ship from the port? So we want to know this right here. How far is he from the port? So as I look at this, I'm like, okay, I've got two sides of this triangle. I just need to know what's this angle right here. And if I knew that angle, boom, I could find PB. I could find the distance of that port, right? So I wonder what the angle is right here. So I have to do a whole bunch of geometry to try and figure out, what do I know? All right. I'll give you a hot second to look at that. Okay, geometry coming back to haunt you. These two lines are parallel. What do you know about interior angles on parallel lines cut by a transversal? I could extend that up a little bit. Sometimes it's easier to see it. Interior angles add up to 180. So that means that this angle right here is 140 degrees. A full circle is 360 degrees. So 140 plus 120 is 260. The whole circle adds up to 300. So 300 minus 260 is 100. I didn't write that right. I was thinking in my brain, how about if I put a 6 right there? The circle is 360. 360 minus 260, I was thinking in my brain 100 as I was writing that. So that means that theta is 100 degrees. One more time. Interior angles add up to 180. So this is 140. 140 and 140 give me 180. 120 plus 140 plus 100 gives me 360. So that's this. Piece of cake now. I just got to find x. Well, remember, c squared equals a squared plus b squared minus 2ab cosine theta, or cosine c. Do I know everything? I certainly do. Remember, I should have highlighted it the other way. Let me find my other highlighter ready to go. Okay, I don't have it quite super quick handy. I'm looking for it. There it is. I like to highlight what I'm trying to find here because I think it helps. This one and this one is what I'm looking at. I'm going to look at these two. This is my side opposite. I still feel like that is so blurry. Maybe that helps. All right. So x squared is my side opposite. It's my c squared. Add up these two. So 40 squared plus 70 squared minus 2 times 40 times 70 times cosine of 100. All right, I'm going to do all that math. Here we go. I'm just going to do all my calculator, y'all. Here we go. I'm going to do 40 squared plus 70 squared minus 2 times 40 times 70 times the cosine of 100. So x squared equals 7472.429. So x equals square root, that big old number, 86.44. How far is the ship from the port? I'm just going to say 86.4 kilometers from the port. Bearings are not that difficult. They're drawing them, I think, is where I get bogged down some. All right, so we're going to do another one of those. Here we go. My mouse is super sensitive, y'all. Sorry about that. Okay, so I'm going to read it from this one because it got cut off on there. All right, let me find my... A ship is sailing around an island, travels 30 kilometers on a bearing of 100 degrees. So he's traveling around an island, travels 30 kilometers at a bearing. So he's traveled 30 kilometers. So let's label that. He's traveled 30 kilometers at a bearing of 100 degrees. So this is 100 degrees right here. To reach point B, as shown on the diagram below. From B, the ship changes direction, and so from this point B to reach point B, we'll call this A. So he gets to B, and when he gets there, oh, my paper's on two different things. From B, the ship changes direction and travels 23 kilometers to point C. And this is 23 kilometers there. Okay, here we go. If angle ABC is 79 degrees, so ABC, so this right here is 79 degrees. Find bearings of C to B. All right, so remember bearings. We're going to start north. The bearings are this. That's what we're trying to find. That's the first one. That's A. All right, so I'm going to give you a second to look at that. We're going to use that same rule we just did earlier about parallel lines and interior angles. Co-interior angles add up to what? 180. So if this is 100, that means this angle right here is 80. If this is 80 and this is 79, can't I find B? You bet. So I'm going to come over here and put A. And I'm going to say 360 minus 79 plus 80. I got 201 degrees. See if you get the same. So that's our bearings. Then we've got part B. You're like, wait, that was it? Yeah, that was it. It's not hard. The bearings aren't, like I said, they aren't super hard. Find the distance from A to C. So let's find this distance right here. I'm going to call that X. Oh my gosh, y'all, what do we know? We know, remember when you want to find the distance on a triangle? If you know the sides opposite or the sides adjacent to an angle, cosine rule, we already know everything. We just need to plug that in. So I'm going to say x squared. Remember the side opposite or the side across from. So I'm going to say x squared equals, I'm going to add up the two sides after I square them. So 30 squared plus 23 squared minus 2 times each of the sides times the cosine of the angle, which is 79. I'm going to encourage you to put all that into your calculator and solve it. I'm going to tell you the final answer I got. I ended up getting 34.14 kilometers. Now, I highly recommend that you pause this video, put that in your calculator, make sure you get the same thing I got. Okay, angles of elevation and depression. Again, this is a geometry thing that I think you touch on again in pre-cal. So this, like I said, this is our pre-cal unit. So here we go. All right, I'm going to get a quick. All right, this first one's pretty simple. So we are doing, oh, this is the ship one. Hold on. I rearranged it on mine. I had to find it. Okay, so two ships leave port at the same time. The first ship is sailing on a bearing of 037, and the second ship is sailing on a bearing of 284 degrees. The path of the two ships is illustrated in the diagram below. Okay, so you can kind of see that. The speed of the first ship is 14 kilometers per hour. The speed of the second ship is 9 kilometers per hour. What is the distance between the two ships after 3 hours? I'll let you look at it. Then I'll start drawing on it. I am going to go ahead and label some points on here. I'm going to call this point A, this point here B, and this point up here C. try. Well, that is not long enough. Okay, I'm just going to wing it. There we go. I'm going to call this side X because it wants to know the path of the two ships is illustrated below. What is the distance between the two ships? This reminds me of that dreaded problem you always hear your parents talk about. If one train leaves a station at this time and another train leaves a station at that time, how long until the trains meet? All right, so let's label what we know. The first ship is sailing on a bearing of 37 degrees. So we know this angle right here is 37. And we also know that the second ship is sailing on a bearing of 284. So from due north, this angle right here is 284. All right, so I do know that. Can I figure out that missing angle right there just because it might be easy? Yeah, I know that all the way around would be 360. I'm really not going to use that 37. I know from here to here is 284. To finish off that right there, I'm just going to take 360 and subtract off 284 and know that this angle right here is 76. Why didn't I use that 37 right there? Well, remember, due north, and it takes all of this right here, is 284, so that little piece missing is 76. And maybe that'll come in to help me here in a minute. I also know, what else do I know? What is the distance? Let's see. Did they give me any other, didn't it give me, let's see. I thought it gave me the, oh, I know what it was. They gave me this, let's see, this ship, speed of the first ship is 14 kilometers per hour, so he's going faster, so he's going to go the furthest. So if he's going for 3 hours at 14 kilometers per hour. So at 14 kilometers for 3 hours, he's going to go 42 kilometers. Okay. This guy over here was going 9 kilometers per hour for 3 hours. So couldn't I say 9 times 3? I'm going to put a little times right there so you know what I'm doing. Is 27. So this is 27. Interesting. I'm going to highlight something on here. Hopefully you're already seeing it. I know this, and I know this, and do I know the angle? I certainly do. 76 and 37, so I know that angle right there. That allows me to find that third side. I encourage you right now, before I write it, to pause your video and try and write out the equation of what you're about to do. Here we go. The opposite side of the angle. So x squared equals 42 squared plus 27 squared minus 2 times 42 times 27 times the cosine of, and I need to real quick do 76 and 37. 76 plus 37, 10, 11, so 113. I'm going to plug all that in my calculator. I'm going to give you the final answer, so if you want to pause it now and get that. But I'm going to tell you that x, which is actually side AC, is approximately, give your answer to the nearest kilometer. I got 58.1306, but to the nearest kilometer, it would be 58 kilometers. Hopefully you're getting the hang of that cosine rule. I mean, gosh, we use it like all the time on this unit. All right, now we're to angles of elevation and depression. Oops, sorry. Oh my goodness, I keep hitting that. All right, so here we go. We got a guy standing up on a ledge, and he's looking down. All right, so this is page 4. My pages are all messed up, y'all. I got to find them. All right, so the world's second tallest tree is somewhere in my paper. Oh my gosh, do I need to pause this so I can find, oh, there it is. The world's second largest tree. There we go. The world's second largest tree is in Centurion in R Valley, Tasmania, Australia. Oh my gosh, y'all, I'm not a reader. It towers above the trees around it as 99.82 meters tall. A forest surveyor is measuring the heights of the other trees around the region. He measures the angles of elevation from the eye level to be 81 degrees and the distance to the foot of the tree to be 8 meters. If his eye level is 1.8 meters above the ground, find the height of the tree to the nearest centimeter. All right. So before we do this, though, I think I need to go over angle of elevation and depression. So I kind of put an example here to kind of help you remember how these work. So remember, wherever your surveyor is, they're going to look across. And then when they look down, just like bearings, start at the top and go down. Okay? Angle of depression is this angle. But angle of elevation, when you're down here and you're looking up, that's your angle of elevation. Okay? And I put that there to kind of help y'all remember which is which. I remember when my boys studied this, it was super hard for them. Okay. So keeping that in mind, now we're to this trees. So these big trees in Tanzania. Tasmania, not Tanzania. So what are we even trying to find on this one? Find the height of the tree to the nearest center. So what you know is this tree towers 99.82 meters tall. The forest surveyor, he's measuring here. And one thing I did notice is the angle of elevation of the eye. So remember, angle of elevation is when you're looking, it's your angle here. Okay, so that would be his angle here. And we know that angle of elevation to be 81 degrees. All right. We also know his height right here was 1.58, right? So just filling in some numbers here that I know. I don't know how tall this tree is. I'm going to pull this triangle off because I think to get the trees out of the way, it makes a little more sense. Okay, so really tall tree right here. We're going to do this right here. Okay, this is going to be my little surveyor guy. Here's my right angle. How tall is this tree? I know that the angle of elevation is 81 degrees. Do I know this? Like here's the tree. Here's the tree trunk. It told me somewhere in here the distance to the foot of the tree from the surveyor is 8 meters. So this little guy is standing 8 meters from the base of the tree and he's looking up at the top of the tree. We want to know how tall it is. Now it did give us that number, 99.82 meters, but you know what? We can't really use that anywhere. It just says that it towers above the trees. So that means like from here to the tippy top is like 99.82. It towers 99 meters above these trees. I can't really use that anywhere. But I do know the angle of elevation is 81. He's standing 8. Can I figure out this? It's a right triangle trig. This would be the side opposite. This would be the side adjacent. So here we go. So let's do the tangent of 81 degrees equals the opposite over the adjacent. So x is going to be, I encourage you to work that in your calculator. Don't wait for me. But I did get 50.51. If you don't work this in your calculator, you're going to lose that skill, and you really want to. Don't rely on me to do that. Okay, so that's x, but that's from the surveyor up to here. I need to remember I had a little piece down here I had to add on because you got to remember he's standing 1.58 tall. So I'm going to say 50.51 plus 1.58 to get that full height of the tree, which is 52.09 meters. Height of the tree to the nearest centimeter. Wait, did they convert those? Find the height of the tree to the nearest centimeter. Oh, but it was all in meters. Oh, I didn't even catch that. Oh, you know what? I think this is the one I wrote cognitive. I remember what it was now. You have to round it to the nearest centimeter, but your answer is in meters. So centimeters is going to be this spot right here. I remember I asked my son about this. I was like, do they want me to convert this to centimeters? He goes, no, they want you to put it out here to the nearest centimeter. So it would be 52.09 meters. It's a little bit confusing on that. I don't think this is a cognitive problem, but if it was, the only other option would be 5,209 centimeters. Anyway, we're going to go that they wanted us to round to the second decimal is what they meant by that. All right. It's an eagle problem. Here we go. Our eagle's sitting on a branch. He must be about to strike at something. An eagle sits at the top of a tree at the edge of the ocean watching a fishing boat. The angle of depression. All right, so let's remember, angle of depression is the looking down angle. It's the looking down. All right, so let's draw this. We know we're going to have something that looks like this, even though we haven't read the whole problem yet. All right, so here's my eagle. Here's my eagle. He's up here, and he's looking down at the boat. And the angle of depression is 24 degrees. And the tree that he's sitting on is 47 meters tall. How far is the fishing boat from the eagle? So here's the eagle. How far is the boat from the eagle? And then how far is the boat from the base of the tree? Here's the base of the tree. We'll call this the base. All right. I feel certain you can do this one on your own. I'm going to set it up a little bit. All right. To find this distance here, I'll call this distance x. I would look at this and I would know the side adjacent, and I need to find the hypotenuse. If I'm doing adjacent, that's cosine. So I would do cosine of 24 equals the adjacent over the hypotenuse. I would solve that for x. Then to find, I'll call this y, to find the base of the boat to the tree. I would want to know the opposite side of 24. So I would be looking at opposite over adjacent. So opposite over adjacent is going to be our tangent. So tangent of 24 is opposite over adjacent. When you solve the first one, oh, you know what I did wrong on that, y'all? I bet y'all notice it too. It's really good that I did this error. Angle of depression is right here, right? My eagle, I need to know this angle right here. I know the angle of depression. That was a really good mistake, Mrs. Dean, because that's something we would all make. I need to go straight across from my ankle, my eagle, my anchor. This is 24. So what is this angle here? It's 90 minus 24. So 66, but we'll do it here. 90 minus 24 is 66. So I'm not going to do 24. I'm going to do 66. That's a really good mistake to make, because we'll all make that mistake. All right. So when I did this on this one, I got x equals, let's see, cosine of 66. So I got 115.55. And then you want to round it to the nearest 3 sig figs, so 116. And then on this one, the distance from the boat to the tree, I got it to be 105.56. And I, again, round that and it'd be 106 meters from the tree. Ooh, I'm so glad I made that mistake, actually, because I think that's one we'll all make. Oh, my goodness. Look at this. This is actually a really fun problem. I think you might see it again. All right. So I know I gave you a whole page on this one to work it. You don't really need a whole page, but this is definitely, if you think you've got this down, pause the video and don't watch it. Just go to the end and see if you get it right. There's a lot going on. This would be an awesome paper quiz from IB. Okay, so let me read it from my paper. The 3D diagram below shows the air traffic control tower CD. Okay, so take a note, CD. We got the tower is sitting up here. And the starting point of 2 runways. The start of runway 1 is at point A, runway 1, and the start of runway 2 is at point B. Points A, B, and C are on the horizontal ground, and the control tower is vertical. So you're kind of thinking 3-dimensional space on this. All right, everything's going to be labeled that I'm about to read here. AB is 230, AC is 340. The angle of elevation of point D from point A is 12 degrees. The angle CAB is 108. We want to first find the distance BC. All right, so let's take a look at this. Whole bunch of information, but it's already labeled, so really we're just kind of looking at this. We want to find the distance from B to C. Okay, so when I look at it, basically I want to find this over here. What is this? But I look and I'm like, oh, I know this side. I know the angle. I know that side too. I can use my cosine rule, right? All right, so I'm going to come over here and I'm going to say A, and I'm going to say the length of BC. So I'm going to say BC squared equals, because remember it's the side opposite, 340 squared plus 230 squared minus the 2ABC. All right, so here we go. So we're going to say 340 squared plus 230 squared minus 2 times 340 times 230 times the cosine of 108. All right, equals. When I put all that in my calculator, this is what I got. 216,830.2579. I took the square root of it, and I got that BC is 465.65. Or BC is 3 sig figs, 466 meters. All right, so I'm going to go ahead and over here and write 466 meters. Bam, letter A, done. Okay, so let's do B. B asks me the height of the control tower above the ground. So here's the ground. How tall is this up? Well, if it's on the ground, wouldn't that be a right angle? Yeah. So what am I going to use? I know this angle is 12. I need the side opposite and adjacent. If I call that x, opposite over adjacent would be tangent. So I'm going to say that tangent of 12 degrees is the opposite over adjacent. All right, so x would be 340 degrees times the tangent of 12 degrees. So x is about 72.269. So x is 72.3 meters. So the tower height is 72.3 meters. All right, so C, moving on. I'm going to put C down here. All right, so what did C say? C says the angle of depression of the start of runway 2 from the control tower desk. Okay, So from the control tower desk, I'm going to kind of go across here. The angle of depression. So this would be the angle of depression. To the runway 2, so here. Okay, so we're going to look down here. Yeah, goes down to this. Okay, this one's an interesting one. That is a very interesting one to ask. Okay, so I'm going to come down here. I wish I had room to put all of it in here. Our control tower is here. Okay, we're going to call that D. All right, so we know that this is C. Now, this is on the ground. So you got to think kind of about three-dimensional space. We are going to go out to runway B, or 2, runway 2. This is on the ground, so this is perpendicular. When you look at it up here, it's kind of like, wait, no, that's not flat, but it is. This is on the ground, so our control tower guy, when he looks down, he's looking down, and it's perpendicular. Okay, so he's here. So this is a right angle, and the ground is flat, and he's looking over here. So what they want us to find is this angle of depression right here that he's looking down at. Well, let's see. What do I know? I know that the height of the tower is 72.3 meters tall, right? Do I know the distance from the tower to runway 2? I do. What's that distance? I found it a while ago. The distance from tower to runway 2 was 466. Okay, can I figure out this angle right here? Yeah. This angle right here would give me this angle, and then I could subtract it to figure out this. But what you're going to discover is that this transversal right here, this angle and this angle are going to end up being the same. But we're going to do it mathematically so that we can figure that out. All right. To find theta right here, I know the side opposite and adjacent. So I'm going to do the tangent of theta equals the opposite over the hypotenuse. So I'm going to take the inverse tangent of 72.3 over 466 equals theta. So here we go. The inverse tangent of 72.3 over 466 is 8.819. So theta equals 8.819 degrees, or 8.82 degrees. 8.82 degrees. Okay, 8.82 plus 90, subtract it from 180 will give me that angle right there. So if I take 90 plus all of that minus 180, it's 81.18. Well, think about what you're going to do. You're going to take that 81.18, subtract it from 90 because you know that's 90, and guess what? This is going to be 8.82 as well. So the angle of depression, is 8.82 degrees. All right. And the last part, D. Okay. Ooh. The airport management is planting more grass to make the airport feel more welcoming to passengers. The triangle ABC. Let's look at ABC. ABC. So this area right here. They want to cover this with grass. So a bag of grass weighs 10 kilograms, and it covers this much this area. The cost is 320 Norwegian krone. How much will it cost to seed the triangle area ABC? Okay, so we need to we need to make this grass, and we need to figure out how much it's going to cost us. So what do I need to know? I need to know the area, right? I need to know the area of triangle ABC. So the area of triangle ABC. Well, if I remember right, I have a formula for area. It's 1/2 base times height, but I don't know the height, and I don't want to spend the time finding the height. So I know that the area of any triangle is 1/2 AB sine of C. AB sine of C. So area equals 1/2 A times B times the sine of C. All right, so let's see what the area of that grassy area is going to be. All right, when I did my math on this, I got a pretty big number. 37,186.309. All right, that was the area, so this is meters squared. Now, I couldn't just stop there. Of course not. It's IB. So what they want to do is, if you read it right, the bag weighs 10 kilograms and it covers 1,156 meters squared. So if this is my total area, if I just divide that, if I say 37,186.309 and divide that by 1156, I get 32.168. So each bag covers this much. So I divided this into that. I got 32.68. So if I get 32 bags, am I going to cover all of it? No, I'm still going to have this tiny little portion that didn't get covered. So I don't need 32 bags. I need 33 bags. This is a great problem, because finding the area, you guys know how to do that. It's pretty easy. You get this number and you're like, oh, I'm done. And then it's like, oh, wait, I got to figure this out. But then you got to use common sense here. You're going to have a little bit left over. So you've got to get that 33rd bag. So now what was the actual question? How much will it cost? You need 33 bags. So grand finale, 33 bags times 320 Norwegian krones. How much am I going to spend? I'm probably not supposed to put a dollar sign, but I'm going to put a dollar sign just so y'all know. 10,560 Norwegian krones. Bum bum. It's a lot of money. All right. And let's see. Are we done yet? Do we have one more page? Oh, we got 2 more pages. We're already at an hour. Oh, this is cognitive. Hey, I'm done. Okay, guys. So now you're on your cognitive part. I will leave it with y'all.